Hi guys, my name is Jay Berg. Today we're going to go over the core technology of DEXCHAIN. We just released a GitHub gist on it, and this is going to be the first of hopefully a series of videos on DEXCHAIN. So we have hard money Bitcoin. Bitcoin is hard money. Those of us that went down the rabbit hole at one point, we got to the bottom of it. We learned what Bitcoin hard money is. What about hard exchange? What is hard exchange? Is there such a thing as hard exchange? Today we want to define hard exchange and see if we could build one. So when you send an order to an exchange, now we're talking about a financial market for risk. What exactly how does it work? What happens? Is it fair? Is it verifiable? Many, just throw their hands in the air and say, I know I get good fills. I buy Bitcoin at $20,000. I get affiliate, I get good fills. I know someone's making money somewhere, but we don't know exactly how it works, but it works for me. So you have three options here. One, you could just shrug it off. Second option, you could take the Bitcoin orange pill and go deep. The third option, which we won't get into here, is try to game the system and make money at all costs. We're gonna go the orange pill route. So let's get started. Hard exchange. The most important feature of hard exchange is price discovery. Okay, we're talking the ultimate exchange, the final arbiter of price for two risky assets. That would be the price discovery. Now, if you have price discovery, you want liquidity, so the most liquid at the best price or the most valid price. Riskless settlement. So you want to be in a safe space. You want to know that when you make a trade, it's guaranteed to settle. Verifiable or trusted. So if it's decentralized, you want it to be verifiable. If it's centralized, it needs to be trusted. Fair access. Everyone has to have access or potential access to the same, exchange place, right? Where, you could hire a broker, you could go yourself, wherever, all liquidity comes together to find the best price and make the trades. Now, front-running resistant, today it's going to be specific towards decentralized exchanges. However, there are some centralized, not necessarily in the Bitcoin markets, but in the equity markets where there is front-running issues. So these are the things that make up the hard exchange. So what is the OG of hard exchanges? The OG of hard exchanges is going to be the trading pits in Chicago. So I'm Bob. I see Alice on the other side of the pit. And I'm bid corn. I want to buy 100 contracts of corn. And Alice is like, sold. And we look at each other, we write it down, and we're filled. We're done. No front running, no asynchronous communication. We're right then and there. We're in a safe space. We both have the right jackets on. We understand, the settlement. We it's trusted, verifiable. Everyone has access. And front running resistant. I mean, you see everything happening in front of you. So, if you're strong and big and you get yourself in the right position, it'll be hard for someone to front run you. So that's the chaotic trading pits. Now, we move to electronic exchanges. So imagine the first electronic exchange wanted to create a limit order book. So we go from the pits where it's just screaming out, bid and asks, and we want to create a fair time price priority where I have a server. Let's say I send 100 bid to the exchange, and that would be I'm first, and the next person says 100 bid, and that would be a two bid at 100. And if somebody wants to go on top of us, they'd have to bid at 101, and you create a limit order book. Turns out we have the Byzantine generals problem. Even on a centralized exchange, imagine trying to build this, using computer science techniques like distributed computing or multiprocessor, or even multi-threaded. Turns out that the state could not keep up. Like even between threads, you wouldn't be able to share state inside the limit order book. So the term central limit order book is not just a centralized exchange. It's actually a single thread and a single server that does the matching for every single symbol on all these exchanges. So that's the exchange matching engine. It's centralized even within the centralized exchange on a single thread. Now, we want to take a look at exactly what's happening. So Alice is a market maker. She puts a buy 1 at 100 and a sell 1 at 102. What I want to do is I want to look at the live markets, and I want to point some things out. So this is live fast orders. This is Bitcoin live, and look how fast these things are moving. This is the last trades. These are the matches. These are the bids and asks, and you see how fast it's flashing. There are 3 things I want to point out here. One of them we see right here. First thing is the markers. You notice the same exact quantity tends to trade in pairs at different prices over and over and over. Every day, all the time, you'll see that. That's one interesting observation. Here's 0.229, 0.229. So we're going to discuss, the strategy behind these. So that's one. So there's 3 things you want to discuss. So first is the quantities in the fills. The next thing we want to discuss is happening too fast, and that's the flashing of orders. So let's go to the videotape for that one. So this is a couple days back, and you'll notice same thing as before. But what we're looking for is bids that show up and disappear, So we've identified this one bot that uses, here we go, 1489. 1489, 1490, 1491, 1492. And you'll notice they never get filled. They always cancel. 1489, 33,412. Let's see. So we're going 1 frame at a time. There it is. It's gone. 1489, 33,412 will be gone. And you'll see, right? It's right back. 1491, 33,413. Now we'll go 1 frame at a time. See how long it takes until he cancels. So 1491. There it is. It's gone. So it turns out this bot, this market maker, whoever he is, keeps flashing orders. 1493 is back. And so here's 1493. It'll be gone in a second. And still there. There it goes. It's gone. So 1493 is flashing. So for some reason, and we'll get to the bottom of why, this bot keeps flashing their orders, and 0.1493, 0.1492, 0.1491 over and over again. And we want to understand what's going on here. The third thing we want to discuss is the amounts, the quantities inside the book. So we looked at here's 0.008. We see that they come in pairs over here, but over here they tend to just be reused over and over again. 909.6423, 909.6846. That's different. 599. So take my word for it. Here, 374. So these are three phenomenons that we see. The most interesting one is the flashing of orders, and the second one is the duplications of the the fills. And the third one is the reuse of the amounts. And let's get to the bottom of it. So back to our market maker, Alice. She's looking for, so she's bid 100, ask 102. She would love it if someone sold at the market, bought at the market, makes $2 free. I mean, that's her objective. However, it gets better. So next thing, Bob comes in and he puts a bid at 99. So now you have Alice, Bob, and this is the market data. This is the book. Now imagine someone sells at the market and hits Alice at 100. So Alice is long 100, and if this happens at this moment in time, Alice is in the perfect position. It's such a perfect position that almost all of Wall Street finance relies on this alpha, because at any moment in time, Alice could turn around and sell 99. So she has she's only risking $1. Now, and she's offering 102. She's long at 100, offering 102. So if someone comes at that moment, if someone hits a market order, she gets 102, makes $2. And otherwise, she sells at 99 and she loses $1. So expected value is 1. This is alpha. And when you hear things like Goldman Sachs had 3,000 profitable days in a row, this is it. How do you have 3,000 profitable days in a row in a volatile market? By taking no risk at all. Now, how do we know there's no risk here? What if Bob cancels? So Alice has to be sure that she could get out. Just on a side note, it will be even better if there were other bids of 100 on top of Alice. Then you actually are risking 0. But to make it easier, we use this example. Now, what if Alice and Bob both realize at the same time that really the market's 98 offer, that it's happening, the market's moving down 2 ticks, and Alice is going to lose, and Bob wants to cancel. So Alice wants to sell at 99 to take the dollar loss. Bob wants to cancel 99. The race is on. This race happens over and over and over, thousands of times a minute. And this is the most classic race in high frequency trading. So who's going to win? Whoever gets to the matching engine first wins. And what do you think? Alice has a trick up her sleeve. Alice's bot is co-located at the matching engine, at the exchange. So she pays the exchange millions of dollars to co-locate, to save the nanoseconds, for this exact reason. So she could hit the bid before Bob could cancel it. So is Alice going to win? Wait a second. Did you see that? 99 flash? Looks like Bob's a flasher. Why is Bob flashing? Turns out, in order for Bob to win, he needs to go faster than the speed of light. How's it possible to go faster than the speed of light? Bob flashes his bid to go faster than the speed of light. So the only way to go faster than the speed of light is a negative, is to do nothing. If doing nothing creates an action, right, in a distant place, right, then you're actually going faster by not doing anything. So this is what happens. So Bob sends an order to buy one at 99. As soon as he sends the order, he's going to go look to try to figure out if there's selling pressure coming in. However, while he's looking, before he gets an answer, he's going to cancel that 99. And then when the information comes back that there's no selling pressure, he sends the bid again. And then he starts looking for the information again and cancels again. And then the information comes in that there is a 90, that the market's about to drop, so he doesn't put the 99 bid back. So by having a negative action to generate, ends up Alice tries to sell 99 and it's gone. And that's the, generic abstract reason for those flashes you see. Obviously it gets more complicated in the real world, but this is just a pointer to the sophistication of exactly what's happening at that level. Now there are two more things that we noticed, right? One is the doubling of the fills, and the other one is the usage of the amounts. So every exchange has two feeds: the market data feed and the fill feed. Now, as a trading bot, let's say today, or let's say this exchange, the fills are faster. If the fills are faster, I'm going to leverage the fact to get the market data by buying and selling at the market using the same buying and selling at the market and getting my fills. Those fills represent the bid ask of that market. So that's why you see that over and over. Now the same on the other side. If the data feed is faster, I want to use the public market data feed to get my fills before my fill feed comes in. Of course, we're talking microseconds and nanoseconds here. So by using unique sizes, I could look at the public data feed and get my fills faster. So this is just an insight into where the market has evolved to. So this is a centralized exchange. Is it a hard exchange? Let's see. Price discovery. Yeah, we have price discovery because we have the limit order books and everyone's coming to that same place. Liquidity. Yes, riskless settlement in context of the centralized exchange because it's trusted. Now, however, there's no fair access. Not everyone has access to the co-location. Not just you're priced out. There are special deals. It turns out that the exchanges are now making more money from the co-location than from just the fees themselves. So really, it's not, the centralized exchanges have no longer fair access. And front-running resistant is not necessarily applicable on the Bitcoin centralized exchanges, but in the equity and BBO exchanges, it does become an issue. So we need to fix fair access. Well, we know how to do that, right? We just create a blockchain, distributed blockchain protocol, and boom, we solved it. So every node is a matching engine. There's no centralized exchange. So there's no co-location, and we solve the fair access. However, we have decentralized limit order books. And remember, we have the Byzantine generals problem. Now, this is different than the Bitcoin double spend problem. This is a front-running problem, which Bitcoin doesn't solve. I mean, those double spends are mutually exclusive. These two orders are both valid, and it's impossible to tell which one happened first. For example, my node has, this is the order I received, the orders. I got a buy at 1 by Bob, a sell at 1 by Alice, and then a cancel came in, which was too late in my book. So my node, my mempool has Bob buys 1 from Alice. Then when it hits the block, I noticed that things have changed. So actually, Bob did get his cancel in, and the trade never happened. And now Alice's offer at 99. Is this front running resistant? No, it's not front running resistant. It's literally front running. So what happened? What we assume is happening, not necessarily what happened, is that Bob's node saw Alice's sell, and based on that, immediately sent his cancel before Alice, and whoever made his block either just received it the way that, put it in the way he received it, or it was, malicious, or it was Bob himself. But the point is that the front running kind of kills the limit order books in the decentralized exchange. I mean, think about the nanoseconds that these high frequency bots are using to try to figure out what's happening. Here they don't have to figure it out, and they have trillions of times more time to manipulate the markets. So our decentralized exchange has fair access, but it's not front running resistant. It is verifiable because it's a blockchain. Riskless settlement. So when you're actually settling on chain, if let's say we use a limit order book on chain, the fills happen. You can automatically deduct the profit and loss, so it is riskless. However, with front running, you don't get the price discovery, and without the price discovery, you don't get the liquidity. So we have a problem. Price discovery requires limit order books. Limit order books don't work in a decentralized way because of front running. So we need a new solution. Well, it is 2021, and we know the solution, right? We create a DEXCHAIN in a DeFi solution, and we do it on Ethereum. So we get verifiable, fair access, and however, there's no limit order book, and Ethereum knows this, and Vitalik knows this. This is why we have Uniswap. So Uniswap gives us the riskless settlement. Uniswap gives us the liquidity, but we need more liquidity than Uniswap. So we use a funding DeFi solution. We use farming. We use I forgot what that one's called. Another protocol to give us the liquidity. So we're getting close. Now we just need price discovery. So we have no limit order book. So we still don't have price discovery. And we don't have front running because we have nothing to front run, right? And here we go. Chainlink gives us oracles to the centralized exchanges externally, which brings in the price discovery. Yikes. What happened? Well, we're no longer decentralized. So we can't really say this fair access. We're no longer decentralized exchange. Now we're DeFi exchange. And it's pseudo-centralized. So there's no fair access. It relies on the oracles, and the oracles rely on the centralized exchanges, and it becomes a big obfuscation problem. And now we're definitely not front running resistant. I mean, it's one big front run. It's much more complex. But this is even worse than the centralized exchanges. It should be worse than the decentralized exchanges, but somehow it's so obvious that the decentralized limit order books don't work that no one's going to use them. Here it's less obvious, so they're being used, and it's creating a new type of trade for the Wall Street, bots. So that's not going to work. So we have a solution. DEXCHAIN is going to solve this problem. And the two main problems is fair access with decentralized limit order books and front-running resistant. And the front-running resistant solution is paying to reorder transactions. So we separate the blocks into two stages. So we start with the mempools. So that's Bob's mempool, and this is Alice's mempool. So again, Bob has his cancel first. Alice has her sell first. And what we want is to come to consensus on the transactions inside the mempool, just the set of transactions. So we want to come to consensus without the timestamps. We just say these are the transactions in the mempool. This is actually a hard problem, and we're not going to get into exactly how we do this. But let's just say we have consensus on all the orders over the past 5 seconds. So we got consensus. These are the orders. Now, how do we generate the actual order book based on this? Well, we have what's called a bidding system. And today, Bob and Alice are both bidding. Bob pays $1 DEX dollar. Alice pays $2 DEX dollars. So Alice wins. These are implemented using, like double spends. So only one of them is valid. And since Alice wins, she gets her order consensus, and which is the buy and the sell at 99, and this becomes final. Alice sold 109, Bob bought 199, the cancel is gone. So we solve front running by doing what, what blockchain has always done, is opening everything up and delaying finality. So we make everything explicit, nothing's hidden. If you want to front run, fine, do it over here, right? Do it later, and this basically solves both. We remove all that gaming from the decentralized exchanges that we saw, because none of that matters anymore, and we stop the front running. It turns out that one of these the main thing that the bots are trying to avoid is not necessarily that 99 to 98, but it's that flash crash, right? So most of the time, the reordering does very little to change the state. But every once in a while, there's a huge move, a flash crash that comes right back up. And you could think of it as like in poker when you run it twice. So major variance that happens in a short amount of time. You have the Heisenberg uncertainty principle, that information is limited to what you could deal with a certain amount of time. So we just say we'll deal with it later, and we kind of run it twice in theory, but in practice this should actually the flash crash should never happen, because none of these bots need to cancel their orders, because they could deal with it later. And there you go, we have a solution. And this is what we want our exchange to look like. So we have Bitcoin, DEX dollars, these will be Bitcoin futures. We want to have deep liquid books, right? We want to have liquid books. So instead of 0.1, we're going to have 5 Bitcoin at $40,000 bid, 4 Bitcoin, $40,250 ask. Yes, it's a large spread, but these all should be real bids, real asks. Even someone trying to make a scalp, but they're not manipulating the book. Price discovery, and no flashing, no need for flashing. So this is what the iteration of a hard exchange should look like. An exchange where you have liquid, real bids and asks coming together to find matches. And what we do is we say, hey, high frequency bots, we know what you could do, you know what you could do, why don't we not do it and do it later? Show me what you can do after the fact. Show me all the front running techniques you could do later instead of live, and that minimizes all the traffic, and we have our book. And one last thing that I want to touch on is how we actually do this with Bitcoin. So we have our DEX sidechain, and we have Bitcoin. So we have the block consensus, which happens on the sidechain. Let's say it happens once every 5 seconds. So there could be 200 of these blocks. Each block is a hash, and if there's more than one block, it's the Merkle root. And then we have this thing called the salt of the order consensus. So when this bid of 1,000 satoshis for hash salt, and this bid of 2,000 satoshis for hash salt, so this one wins. The hash salt goes into the, using the space chain idea, the hash salt goes into the Bitcoin block, and turns out you take the salt and you use it to create the canonical ordering of the transactions within the block, and this becomes a little proof of workish. And we get more into the details of this next time. Again, this is just the core innovation, the core tech, and a little insight into what and why. We're excited about to actually build this, and we want to get feedback, get people interested, and the other parts of the proposal, which deals with the futures and the Bitcoin side and the DEX dollars. Hopefully we'll do another video with that. And just to sum it up, DEXCHAIN is a hard exchange. We have price discovery, with limit order books. We have liquidity because we have price discovery with limit order books. Riskless settlement happening on the sidechain. And verifiable, when especially when it hits the Bitcoin blockchain. Fair access, everyone can have a node. And it's front-running resistance with our reordering of the transactions. And there you go. That's the DEXCHAIN. It was released on January 21st, 2021. Reach us on Telegram. That's where we're at right now. My Twitter is JBNY. And everyone should check out the gist on GitHub. Hopefully, there'll be a link below. Thank you so much for your time. And looking forward to chatting with all of you again. Thank you.